let's just move on towards the another property, which is nothing but the associative property. That is the last property of the rational numbers, but we'll again check this property on all the three numbers again. First of all, we'll talk about the whole numbers. The second, we'll talk about the integers, and the third, we'll talk about the rational numbers. Means we'll check that whether the whole numbers are associative in nature, whether the integers are associative in nature, or whether the rational numbers are associative in nature under the four basic operations of mathematics, that is addition, subtraction, multiplication and division. But before that, we have a beautiful fact about the word associative. So what is the fact about the word associative? That is, the word associative actually comes from a Latin word which is called as associare. Associare is a Latin word. So the word associative actually comes from this Latin word, which means that the meaning of this word is nothing but together. It means together. So here we'll take any three numbers and we'll apply the basic four operations on all the three numbers in the different order, and we'll check that whether they are associative under the different operations or not. So I hope this fun fact is all clear to you, that what is the meaning of the word associative. So let's just start the associative property for the very first number, that is for the whole number. So let us suppose I'm taking the collection of the whole numbers as W. So this is nothing but it includes the collection of the numbers as 0, 1, 2, 3, 4 and so goes on. So first of all, under addition, we'll check whether the whole numbers are associative in nature. So for the associative property, we have to take any three numbers out of this particular collection. Any three numbers out of this particular collection, and we have to check that whether or not A plus B plus C or A plus B plus C, they are equal or not. So what is the meaning of associative property? The meaning of the associative property is that whenever we'll take any particular three numbers or any particular three whole numbers, integers or rationals, or we add them in any particular order, the answer will always be the same. If this property holds, it means that this is nothing but associative property, which holds for the whole numbers under addition, subtraction, multiplication and division. So this is the case for the addition. We are taking any three particular whole numbers A, B and C, and we are adding them, and we'll see that whether they are equal or not. So let us suppose I'm taking any three whole numbers out of the collection of the whole numbers. Let us suppose I'm taking 0, 1 and 2. So for the first case, I'm adding 0, 1 and 2 in this manner, where 1 and 2 are in the bracket and 0 outside. For the second case, I am taking 0 and 1 in the bracket and 2 outside. So the answer of the first one will be 0 plus the bracket. The answer of the bracket will be 1 plus 2, which is nothing but 3. And for the second case, the answer of the bracket will be 0 plus 1. It is nothing but 1 plus 2. So 0 plus 3 is nothing but 3, and 1 plus 2 is nothing but 3. So the answer of both of them is nothing but same. It means that A plus B plus C is equal to A plus B plus C for the case of addition, where A is 0, B is 1 and C is 2. It means that addition is associative in nature for the whole numbers. Whenever I'm taking any three whole numbers like I did, or like I've taken over here as 0, 1, 2, and we are adding them in the different manner like A plus B plus C or A plus B plus C, the answer will always be the same. So it means that addition is associative in nature. So let's just move on further towards subtraction. So let's just take any three whole numbers again, and for the same case we have to check that A minus B minus C should be is equal to A minus B minus C. If this property holds, it means that the whole numbers are associative. If not, then the associativity property will definitely does not hold. So let us suppose I am taking any three numbers, let if 1, 2 and 3, and I am subtracting them in the different manner, means 1 minus 2 minus 3 in the first case, and in the second case I am subtracting 1 and 2 in the bracket and minus 3 outside. So the answer of the first one will be 1 minus, will solve the bracket as 2 minus 3 is nothing but minus of 1. So the answer is 1 minus minus is plus. So 1 plus 1, the answer is nothing but 2. But for the second case, the answer will be, will solve the bracket 1 minus 2, the answer is nothing but minus of 1 minus of 3. So this is minus 1 minus 3 and the answer is nothing but minus 4. So the answers are not equal to each other. The answers are not equal to each other. It means that A minus B minus C is not is equal to A minus B minus C, which means that the property does not hold. Hence, subtraction is not commutative in nature. Because of this particular example, we have concluded that A minus B minus C can never be is equal to A minus B minus C as per this particular example. So this shows that subtraction is not associative in nature. Let's just move on further towards multiplication. Let's take another three whole numbers again, and we have to conclude that A into B into C should be is equal to A into B into C. If this property holds, or if this condition holds, the multiplication should be commutative, else, multiplication is associative. Or if this property does not hold, then the property obviously is not associative in nature, or the whole numbers or the multiplication are not associative in nature. So let us suppose I am taking any three particular example, 1, 2 and 3, or I'll take 2, 3 and 4, let us suppose. So if I'm multiplying 2 into 3 into 4 in this manner, or if I'm multiplying 2 into 3 into 4 in this manner, so let us suppose the answer of the first one will be 2 into 3 into 4. When we'll solve this particular bracket, so the answer will be 3 into 4, which is nothing but 12. So 12 into 2 is nothing but 24. But for the second case, 2 into 3, it is nothing but 6 into 4, and the answer is 24, which means that both of them are equal to each other. Hence, A into B into C is equal to A into B into C, which means that multiplication is associative in nature. Because of this particular example, we have concluded that multiplication is associative for any three whole numbers, as A into B into C is equal to A into B into C. So let's just move on further towards division. In the same way, or on the same note, we have to conclude that A divided by B divided by C should be is equal to A divide B divide C. If this particular condition holds, it means that division is associative, else division is not associative. So let if we are taking any three particular example, or let if suppose we are taking any three whole numbers. So let if I'm taking 1 divided by 2 divided by 3. So 1 divided by 2 divided 3. So the answer of the first one will be 1 divide 2 divided by 3 is nothing but 2 by 3, and 1 divide 2 by 3, it means that 1 is in the numerator and 2 by 3 is in the denominator. So the answer is nothing but 3 by 2. But for the second case, 1 divide 2 divides 3, the answer will be 1 divided 2 means 1 by 2 division with 3. So this is nothing but 1 by 2 in the numerator and 3 is in the denominator. So the answer is nothing but 1 by 6. So are they equal to each other? No, they are not equal to each other. and hence we concluded that A divided B divided C should never be is equal to A divide B divide C. So at the end, what will be the answer? That division is not commutative in nature. Why so? Because this condition does not hold. If this condition will hold, then the division is associative in nature. So at the end we get that associative holds for addition and multiplication only, not for the subtraction, not for the division. I hope associative property for the whole numbers, for addition, multiplication, subtraction, division is all clear to you.